Last time we were together, we were talking about writing linear equations, specifically in point-slope form. Today we're going to look at writing equations of linear functions in all three forms. So there's point-slope, which we talked about last time, which is y minus y1 equals m times the quantity x minus x1. And the important thing about this form is that m represents the slope, and x1, y1 comes from a point, any point on the line. The benefit of this form is it's easy to make. Any 2 points on the line and we can make this form. The bad news about this form is that it's kind of messy to really use for anything. So usually if we're given 2 points, we'll start by making point-slope form, and then we'll turn it into one of these other two. So the next one on the list is slope intercept form. Slope intercept form is y equals mx plus b. I think this is the one we're probably most familiar with. Okay, the m represents slope still, b represents the y-intercept, which is the point where that function crosses the y-axis. What's important to note at this point is that this is where x is equal to 0. Whenever x equals 0, the y value of that point is the y-intercept. This is really good for graphing and for cause and effect relationships because that y is all by itself. So we can sub in values for x, or the cause, and we can get out the y or the xy points and put those on the graph. But in order to make this equation, we need b. We need the y-intercept, and we don't always have that right from the jump. But any 2 points at all, we can make point-slope form and then turn it into slope-intercept form. It's not very great for algebra, but it does have its uses, like we said, with graphing and with cause and effect relationships. Then the last one that we have is standard form. Now standard form's, oddly enough, probably the one we're least familiar with. Standard form is ax plus by equals c. And there's nothing really special about what a, b, and c represent. They don't represent any important part of the function. What they represent are simply integers. They have to be integers. There's no fractions, there's no decimals in standard form, which makes this form really good for algebra, specifically solving systems of equations. It's not always easy to make right out of the gate. Usually you have to start at point-slope form and then take it through standard form. But once it's in standard form, it's great for algebra. So now, let's take a look at a couple of examples. Okay, and we're going to take these equations through all three forms. So we're going to start with just the points. We're going to put them into point-slope, send them into slope-intercept, and then take them all the way to standard form. So first off, I've got 3, -2, and -1/6. The very first thing that I want to do is label them x1, y1, and x2, y2. Now, if I'm going to put them in point-slope form, I've got x1, y1. The other thing that I need to find is slope. Okay, so m is going to be equal to 6 minus -2 over -1 minus 3. Now minus a negative becomes plus plus, so 6 plus 2 is 8 over -1 minus 3 is -4, and our slope is -2. Now once we have our slope and we have an x1, y1, we can sub them in to point-slope form, and we'll have y minus -2 equals, okay, y1 was -2, our slope is also -2, times the quantity x minus our x1 is 3. Now this is point-slope form, and the only thing that we would change here is we don't like to keep two operators back to back. So minus a negative, we'll just make that plus. So y plus 2 equals -2 times the quantity x minus 3. And this is point-slope form. Now once we have it in point-slope form, we can take this and change it to slope-intercept. So what's really important to note about all three of these forms is they all include an x and a y. And x and y don't get replaced with numbers. Those stay x and y, and that's really what makes the function a function. But point-slope form, the big difference is between this and this, number one, are the parentheses. Okay, I want to get rid of those parentheses from point-slope form. And the way that we'll get rid of those parentheses is we'll distribute. So I'll take this -2 and distribute it over that quantity. and I'll have y plus 2 equals negative 2 times x is negative 2x. Bring down that minus sign. Negative 2 times 3 is negative 6. Okay, now minus and negative will become plus plus. Okay, the other big difference between what I have now and this slope-intercept form is here, y is by itself. So I'll isolate y. I'll subtract 2 from both sides. And I'll have y equals negative 2x plus 4. And this is slope-intercept form. Okay, so for point slope, I have y minus y1 equals m times the quantity x minus x1. For slope-intercept, I have y equals mx plus b. Now, last thing that I need to do is get it into standard form. And the big difference between points or slope-intercept and standard form is in slope-intercept, y is all by itself, but in standard form, I have ax plus by. I have both variables on one side. So now I need to move these x's over to the left. So I'll add 2x to both sides, and I'll have 2x plus y equals 4. And this is standard form. So we were asked to find all three forms of the equation of a line through these points. Here we go. Here's point slope, here's slope intercept, here's standard. Okay? Now let's take a look at another one. Here we have 3, 5, and 0, 3. Now we're going to start out the exact same way. We're going to label those points x1, y1, and x2, y2. Then we're going to use those points to find the slope. Okay, point slope form, that's the only thing I'm really missing. I have an x1, y1, now I need a slope. So my slope is equal to 3 minus 5 divided by 0 minus 3. Okay, y2 minus y1 equals x over x2 minus x1. 3 minus 5 is negative 2. 0 minus 3 is negative 3. So I have negative 2 over negative 3. Now a negative divided by a negative is a positive. So my slope here is positive 2/3. Okay, now I have my slope, I have an x1, y1, I'm going to sub those into point slope form. So I have y minus, my y1 is 5, times the quantity, x minus, my x1, whoop, got a little ahead of myself, y minus y1 equals m, which we found is 2/3, times the quantity, x minus, our x1 is 3. Well, there's point slope form. So here we go. Next up, I want to find slope intercept. And again, we said the big differences between point slope and slope intercept is one, the parentheses, I need to get rid of those. So I'll distribute that slope. And the other part is I want to get y by itself. So I'll distribute the slope and I'll isolate y. So I'll start by distributing that 2/3. So I have y minus 5 equals 2/3 times x minus 2/3 times 3. Now if we need a calculator we can use one, but the benefit right here, put that 3 over 1, multiply straight across, and we'll have 6 over 3, which is just 2. In other words, those 3's are going to cancel. And we'll have y minus 5 equals 2/3 x minus 2. Now I still need to get that y by itself, so we'll add 5 to both sides and have y equals 2/3 x plus 3. Now that y is all by itself, no parentheses. This is slope-intercept form. Now the last bit is I want to have standard form. So I want to have x and y on the same side, and I want to have no fractions. So I'll start by subtracting 2/3 x from both sides. So negative 2/3 x plus 1y equals 3. Now, I've got x and y together, but the catch is a, b, and c must all be integers. So I'm going to show you a little trick that we can use here to get rid of this fraction. The first thing that I'm going to do is rewrite all of these terms with a common denominator. So I have 1 over 1y and 3 over 1. But I want them to all have the same denominator as this guy. So I'm going to put them all over 3. So I have negative 2/3 x, okay, that stays the same, plus, now for this y, I've got 1 over 1. I'm going to multiply by 3 over 3. And that's going to give me 3 over 3 times y. Equals, now I'm going to do the same thing with the 3 over 1. Multiply by 3 over 3. And I'll have 9 over 3. Now the reason we do that is because this next step makes everything go a whole lot more smoothly. We're going to multiply both sides of this equation by 3. Whatever this common denominator is for all three of those terms, we multiply both sides of the equation by it. Now what this does for us is cancel all of those denominators all at once. And what we're left with is negative 2x plus 3y equals 9. Okay, now this is standard form. ax plus by equals c, and they're all integers. Here we go. Okay, this one's standard form. So this one, I like to call this the smiley cancel. Because once we get that common denominator, and we multiply both sides by that common denominator, what that does is cancel all of those all at once. And if I draw a curve through them all, it kind of looks like a smile. Okay, now my equation's happy because it doesn't have any fractions in it. Okay, so this is point slope. Y minus y1 equals m times quantity x minus x1. Slope intercept is y equals mx plus b. And standard form is ax plus by equals c, all integers. Okay, tell you what, let's take a look at a couple more. I'm going to get an eraser. Okay, now we have the same directions. I'm going to give us a couple of points, and we want to find all three forms of the equation that goes through those points. So next up, we have 8, negative 9. And negative 16, 0. So 8, negative 9, and negative 16, 0. Okay, now the very first thing that we need to do, if we're going to sub them into point slope form, we need to have the slope. We need to label our points. x1, y1, x2, y2. Then to find our slope, we do y2 minus our y1 over x2 minus our x1. Minus a negative becomes plus plus, so 0 minus negative 9 is 9 over. Negative 16 minus 8 is negative 24. Now we can reduce this, divide each of these by 3, and we'll have negative 3/8. So we have a slope, we have an x1, y1, we're going to sub those into point slope form. So y minus our y1 is negative 9 equals our slope is negative 3/8 times the quantity, x minus our x1 is 8. Now this is just about set to be listed as point slope form. In fact, it is in point slope form, but we don't like to keep two operators back to back. So that minus a negative becomes plus plus. and we'll have y plus 9 equals negative 3/8 times the quantity, x minus 8. And here we go. Point slope form. Okay, then, if we want to change this to slope intercept, the big difference, we need to get rid of those parentheses, distribute, and we need to isolate that y. So we'll start with the distributing that negative 3/8. So y plus 9 equals negative 3/8 x, bring down that minus sign, negative 3/8 times 8. Now, it worked out pretty nicely for us again. Put that 8 over 1, multiply straight across, and we'll have 24 over 8. Well, that will reduce down to 3. So what happens is those 8's cancel. So I have y plus 9 equals negative 3/8 x minus a negative becomes plus 3. Last little bit, need to get that y all by itself, so I'll subtract 9 from both sides and have y equals negative 3/8 x minus 6. And this is slope intercept form. There we go. Okay, last up, I want to get this into standard form. Now for standard form, I need to get x and y onto the same side. So I'll start by adding 3/8 x to both sides. So I have 3/8 x plus, I'm going to say 1 over 1 y equals negative 6 over 1. Now, if I write each of these with a common denominator, put them all something over 8, okay, the 3/8 x gets to stay the same. Plus this 1 over 1 y, multiplied top and bottom by 8, and I'll have 8 over 8y equals, for the negative 6, multiply top and bottom by 8, and I'll have negative 48 over 8. Then we do that smiley cancel. We multiply both sides, the entire equation, by 8, and all those denominators cancel, and I just have 3x plus 8y equals negative 48. And here's standard form. Now, you're not often going to be asked to find all three. Okay, basically they're going to give you the points and tell you to do one. So if they tell you to do point slope, you can stop right here. If they tell you to do slope intercept, you're going to have to work through the slope intercept. And if they ask for standard, well, then you're going to have to work all the way through. But the key is to make sure you're answering the question that's asked. So right now we're asked to find all 3 points, or excuse me, all 3 forms of the equation through those